In this video, we're going to take a look at how to create a class library with ASNA Visual RPG. Class libraries, or DLLs, are a great way to share code, business logic, file I/O access, special case routines. They're a great way to share that kind of code across projects and across a development team. Class libraries can be used in browser-based applications, Windows-based applications. It's a great way to share a common code base across Windows and browser-based applications, for example. So in this video, we're going to be using ASNA Visual RPG 11 with Visual Studio 2012. But most of what we talk about will work with most late versions of ASNA Visual RPG for .NET. So we're looking at Visual Studio 2012. So let's get started. Our example here is going to be a little math class to calculate the area of a circle. A really simple example, but it shows us all of the mechanics that we need to see this in action. As I said, you'll typically be doing larger business-related things with declare disk files and lots of I/O and lots of interesting things going on. This is very basic and simple, but it's the mechanics of creating a class library and then consuming it that we want to show in this video. So let's get started. We'll say File, New, Project, Visual RPG, Class Library. Now, I've got a folder out here called Other. That's where I put my non-browser-based applications. And I'm going to create a top-level folder in that Other, so I'll be able to sure to find this. Math, Class, Library, Demo. Now, inside that, I'm going to create two more folders. Math, Class, Library, Demo, and then Math, Class, Library, Consumer. So what I'm going to do, my intent is to put the class library here and the consumer here, both of which are living under the Math, Class, Library, Demo. Whoops, and I made a mistake. That's not supposed to say Demo. That's supposed to say Math, Class, Library. So we'll select that. Click Select. Now watch what I name the project. I'm naming the project asnahelpers.math. This will result then in a DLL named asna.helpers.math.dll. I like that fully qualified naming because this is also going to imply that we'll have a namespaced class library, and it'll be easy to find out on our file system. So we've done the selection of the language, the class library, where to put it. Let's click OK. Make it a little bigger. So let's first of all do a little housekeeping here. Let's rename the class, and let's get rid of this name here. I named the project asna.helpers.math, so the resulting DLL would be named that. But I don't want the namespace to be that. I want the namespace to be asna.helpers. I may come back later and add other classes to the ASNA helpers namespace, maybe a string class or a file I/O class. Now we'll come into here and we'll say we're going to start with a constant. And our constant value is going to be 3.114159. And then we'll write us a little function that returns a packed 12,5 number. Now I like to have a result field that I use to return the result of functions. So if I do this, I've now got that function sort of stubbed in and ready for me to write code for it. Now this function needs a parameter passed to it. So it needs a parameter of the radius of the circle. Then it's easy. Result equals radius times pi. Whoops, where'd that 1 come from? Okay. So we've got this method that we added to our class, circle area, and it's going to square the radius, radius times radius, and then multiply it by pi. That's how we return the area of a circle. Now, I'm almost going to make a very easy mistake to make. I almost forgot to mark this method public. If we don't mark it public, it doesn't get surfaced as a public member. It can't be consumed by consumers. It can't be seen by consumers. So I think we've got our little function written, our little class library written. Now remember, this doesn't have an entry point. If we try to run this, it's going to say, I'm not able to start this thing. It doesn't have an entry point. That's okay. That's supposed to be that way. Let's build the solution. Build solution. See if it compiles. It did. Now let's go check our, oh, we forgot to do something here. We named the class, but we ought to also name that source file to match the class. Let's get that real quickly. There. That suits me better. Now let's go look at our output. We don't have to, but just to be good, let's rebuild it again since we made that change. It's not going to change the binary output, but if you're anal retentive, you'll feel better about it. Now let's go look at what it created for us. It created, in the folder that we told it to, a bin folder, a debug folder. There is the fruits of our labor. That's the DLL. That's the binary file that we're going to distribute across machines to use this. So if it's in a browser-based application, this is what we put on the web server. Windows application, we need to put this out on each Windows machine. We'll come back to that in just a little bit. Now, a couple of ways we could test this. I like to build a Windows console test harness for the class libraries that I build. So let's put that test harness inside this same solution. So we'll come up to the solution and we'll say, add a new project. Now this new project is going to be a console application. Where do I want to put it? I want to put it right there in that consumer folder that I created. So we'll call this Math Class Library Consumer. This console application is sort of an unused little gem. We don't notice very many people reporting bugs to us with console applications. I really like using them for this kind of work. They get the weight and the cumbersomeness of Windows applications and browser-based applications out of the way. We just have a DOS box that's going to pop up that we can write to, and we can see what's going on. We can debug with it. I think it's handy. Now, we named our class library, our DLL, asna.helpers.math. First thing we need to do is set a reference to it. So I'm going to come into here and say add reference. We could browse for it, but since we have a multiple project solution, we can just set a project reference, say OK. And there we'll see asnahelpers.math in our references. Now we could also say view object browser, and we could see that in the object browser as well. There is our helpers.math, there's our namespace, there's our math class, and there's the 2 public members in that math class. You can click one of them, you can see its signature down there. Pretty handy thing. So now, in this guy here, we need to set an instance of that guy. Math operations, MO. Type asna.helpers.math. New. I'm making a fully qualified reference to that math class. I need to be careful. Some of you who have done class libraries before may be thinking, why don't you just use a using statement? Well, I could, and we'll revisit that. We'll come back to this in just a moment. Let's first of all see some output here, and I'll show you why this needs a fully qualified reference. Now let's declare a couple of variables. Let's declare a variable that's radius. And then let's declare a variable that is area. and let's say radius equals 12.5. Area equals MO. And IntelliSense should show us the two public members, and there they are, circle area and pi, right there and right there. The other 5 members, of course, it got from system.object. So we'll say circle area, radius. That'll calculate the area of our circle. And then we'll do this, console.WriteLine, the area of a, stick with me here, is so what I'm doing here, maybe you've not seen this. Let's crank that down one size for just a moment. I'm using some string.format magic that's built into the WriteLine method of the console object. If you're not used to string.format, look it up. Lives in the system.string namespace in .NET. This lets me give it a text with placeholders, variable number of placeholders, and then as many arguments as I have placeholders, and it'll fill it all in for us. Don't have to use a bunch of concatenation and stuff like that. Here's a blast from the past. Press any key to continue. Don't see that very often anymore. And then finally, the console will just fly on by if we don't do this. There we go. So now we've got an instance of our class library declared and instanced. We've got a couple of worker variables. We're setting radius to 12.5. We're setting the area. We're going to call it. We could have put 12.5 here. Let's run it. See if we're living right. Oh, look. Not able to run this thing. Why is that? That's because I forgot to do something. That's the class library. See how it's bold? I need to take this consumer and say, you are the startup project. Now, once I tell it it's a startup project, it's a console application. It has an entry point. .NET's happy to run it. Now, this DLL gets bound at runtime. So there we can see that the area of a 12.5-inch circle is 490.87343 inches. Press any key to continue. So there we can see that we've consumed our class library. Now, let's go over here and let's go right to here. Let's say we want to debug this class library. Let's put a breakpoint in our class library code. So I'm putting a breakpoint here in this math member. He's in the DLL. Now we'll run it again. But this time, before we see, well, I guess we see it, there's the DOS box. We'll get out of the way for a second. There we can see that we hit on the breakpoint of that circle area method. We can hover over something. We can see that we've passed in 12.5. So you can debug these just like anything else. The challenge is you've got to have some sort of a wrapper or consumer that's using the class library, because you can't run a class library on its own. And again, I typically use a console application with that. Let's drag this back over here and tell it to run. And there we go. So the debugging of a class library is just like the debugging for AVR. However, you've got to have you've got to be debugging from a consumer. Windows program, browser-based application, or a console application like we're doing here. Now, let's take a look at our consumer here and look at one more thing out here on the disk drive. Let's see what it produced for us. In our consumer, let me just prove to you something. In our class library, got a bin folder, debug folder. There's the DLL, the fruits of our labor. But now take a look at, here's the consumer, here's the console application. In his debug folder, you might be surprised to see there's the executable. We would expect that. And by the way, if I just double click it, there we can see this thing running. That's the executable. You would expect to see that. But when we set that reference, .NET pulled in that DLL. So this is what .NET meant all those years ago when .NET said it would get you out of DLL hell. In the old days, in the COM days, you would have had to take this DLL and register it with the Windows machine. It went into the registry. It was easy to mess up. It was hard to update. It was just a problem. And now we have no registry knowledge of this DLL. What .NET does is it looks in the same folder as the exe to look to resolve these DLL references. DLLs are bound at runtime. So these two programs are compiled independently. If you make changes to the consumer.exe, you don't need to recompile the DLL. And if you make changes to the DLL, you don't need to recompile the exe. The only exception to that might be careful, and this is pretty obvious, but if you go into your class library and make a change to the signature, for example, add a second parameter, then of course you would have to make changes and recompile your consumer. So we've seen the debugging, we've seen consuming it. One more thing. We could have generally not needed to make a fully qualified reference here to this. We could have just, what you'll often see is, let's make this larger again. What you'll often see is to come up here and say, using system, ASNA .helpers. And then down here, this would resolve to that. The problem with that is there is a system.math class provided by .NET. So watch what happens if we try to build this program, this console application. Now it fails. And it says system.math is abstract. You can't instance it. It thinks that you're trying to instance the system.math class, not the ASNA.helpers, because the .NET classes that are similarly named to your classes take precedence. So we don't want to do that. We could have fixed this two ways. You could have left the namespace there and then came down here and sort of halfway fully qualified it. Now that's going to compile. Let's make sure that compiles. That compiles. Or you could have just, and this is probably what I would have done, just left that at a fully qualified reference. So when you have a collision, you need to fully qualify the reference to one or the other on these ambiguously named classes, or these, not ambiguously named, but classes that are named the same as those in system. Be careful. You probably need to fully qualify it. Read the error messages carefully. They generally make sense. So that's it. That's how to do it. You create a class library project, you set a reference to it, and then you get on with your life using the class library. It's great. We set a project reference, but we could have also come in here and said add reference, and we could have gone out and just browsed for it out on our machine as well. So I think that does it for this video. That's how to create a class library and consume it with ASNA Visual RPG. Thank you very much for your time.